Okay. Hi, welcome to the Kubernetes community updates for this week. My name is Valerie Lancy. I work at Lyft doing a mix of downstream and upstream Kubernetes work. Today we have a pretty busy schedule. We have our usual SIG updates. We have information about the latest release, and we have 2 demos. So in just a sec, I'll kick it over to the demo. First, a reminder, we do have the CNCF Community Code of Conduct. Make sure that you abide by that when participating. We could simply sum it up as be excellent to one another. So now let's kick stuff off to Darren demonstrating K3s.
Of course, let me unmute and share my screen here. Okay. All right, hopefully everyone can see. All right, thanks for having me. I'll try to keep this short, 10 minutes. I just did a meetup on K3s that was 2 hours long, so I've really got to condense this down. But basically, so what I'm presenting here is K3s or K3s, however you want to say it. A lot of people ask what the name means. It doesn't actually mean anything. It's just kind of a geeky thing of Kubernetes is K8s, which is a 10-letter word. So K3s would be a 5-letter word, which is half the size. So we want a lightweight Kubernetes, so we picked a shorter name. So I'm Darren Shepard. I'm from Rancher Labs. We built K3s, co-founder, chief architect, do my best to participate in the community and do a lot of stuff with Kubernetes. So, so basically K3s, what's the basic goals of this? It's really for running Kubernetes in resource-constrained environments. We've done a lot of marketing around Edge. That's an obvious, immediate business use case we have, but there's a lot more things that we can do besides just Edge. It's just the basic idea of, we think to manage Kubernetes offerings like GKE, EKS, AKS, those are great. But there's other use cases for Kubernetes, especially Kubernetes architecture, our operators, there's a lot of things we can do with Kubernetes in different environments. So these are things like, Edge and IoT or dev and test. But there's also other use cases like single app clusters where you're going to end up with a lot of clusters that just might be a couple servers. Or you want to embed Kubernetes effectively into an application. Like you want to be able to deliver a microservice application to a customer and it's powered by Kubernetes, but you kind of want to package Kubernetes with it. There's a lot of use cases we see like that for OEM software and whatnot. And so K3s was just designed to, I think the best way to describe it for people who know the Java world is our goal is kind of become like the Jetty of Kubernetes. We just want to be the lightweight, slimmed down, kind of flexible, embeddable Kubernetes. So basically, what does that mean? Fundamentally, what are we doing with this? And so first and foremost, we're a lightweight Kubernetes distro. What that mostly means is that we reduce the memory, the base memory footprint. And that honestly just means removing a lot of code. I'll go into the next slide in detail what we removed, but hopefully it shouldn't be anything that causes a big impact. Sorry, there was one point that I forgot to make on this last slide, was that everything we're doing with K3s is intended to be production quality and fully certified. So we are already CNCF certified. We passed all that certification. We did that with day one. And we are going towards production. So this is not just dev and test. So it's important that, kind of everything works. So when I talk about we've ripped out code and whatnot, it doesn't kind of hinder the functionality of Kubernetes in a way. It's more of, we took a little bit more aggressive step in removing things that are most likely going to be removed already or are not really used. So first and foremost, we're a lightweight Kubernetes distro. And then kind of second is we're a very simplified package. Now, anytime you say the word simple, that means that, basically, there's pros and cons of simple. So we've done our best to have same defaults and secure by default. But we obviously make choices for the user. So there are specific choices and things that we've done. We try to make it so that there's a default same behavior, and then you could turn it off and customize it however you want. But we've packaged this up in a really simple way, and hopefully you'll see that in the demo. And kind of along with that packaging is that it includes absolutely everything. There's no user space dependencies, which means we technically kind of include, like we include even things like IP tables and SOCAT, some of the host level utilities that Kubernetes needs, but we also include the container runtime. It's still optional, but by default, we package containerd. And it's all packaged into just one simple binary. So just kind of technical details of how do we do this. And most thing is like what we did to remove stuff is we removed like legacy and non-default features. Like, so that means a lot of emission controllers that are not on by default. Most cloud providers don't allow you to customize them. You know, you really shouldn't be using a lot of these things because it kind of impacts your portability. So we removed a lot of emission controllers. We removed some of the really old APIs that just aren't being used anymore, and we really don't see any use in the wild. All alpha features are dropped. And then anything basically that's like an in-tree driver or plugin that has an out-of-tree equivalent, we got rid of. And so that's like cloud providers, drivers, storage drivers. So if we don't have a huge use case in K3S for cloud providers because that's not our target, it's the kind of that cloud. You might as well just use GKE or whatever. But if you want to use a cloud provider, you will be using the external ones. And then for storage, it's just pretty much all CSI. And then the last thing is we took out Docker, and we by default run with containerd. Any CRI runtime will work, but we package containerd by default. And that ends up cutting out quite a bit of memory. So those are the things we ripped out. The things we added is there's a wrapper that makes the installation really easy. You'll see that in the demo. We use SQLite instead of etcd. Well, it's in addition to etcd. This makes it even smaller and simpler and whatnot for these resource constrained environments. We do all the TLS management pretty much like automatically. With some built-in functionality to automatically deploy manifests and Helm charts. So it just makes it really easy to package up an application with this. Because you just need to package up, like you just have the K3S binary plus some manifests, and then you just start it and it will fully deploy your application. And then we just included all the other things you need, like containerd, CoreOS, Flannel, and whatnot. This is kind of like your basic architecture. I assume everyone here on this call knows Kubernetes architecture, but the things that we did differently is, if you can see the processes, is we combine things into single processes. Again, like if you're running a large scale cluster, obviously it makes sense to have these as separate processes. If I'm running a smaller scale cluster, it doesn't matter so much. So we didn't break any of the control data plane separation type things, but we did combine processes. So it's like the kube proxy and the kubelet are one process. Flannel is actually embedded in the same process. But one of the key things that we did is this tunnel proxy. If you look at this diagram, is the agents only make outbound connections to the server. So we have this tunnel proxy. So basically it establishes a long-lived tunnel to the server so we can do reverse connections through it. This makes deploying Kubernetes a lot easier because you don't have to work with firewalls and allowing inbound connections, and it allows us to kind of span security zones and things like that. So it just makes it a little easier for people to get going. Okay, so I'll get to the demo. So I'm going to be demoing on 2 machines in Amazon. The simplest way to do K3S is a curl script. I'll show that at the end, but I'm just going to kind of do the raw thing so you just kind of see what's happening. These machines are ARM64. I don't think I mentioned this before, but like by default we support x86, Intel 64-bit, ARM 64, and ARM v7. And so all those are tested. Binaries are immediately available. We have multi-arc binaries and whatnot, or multi-arc images. Okay, so in order to get, so basically, if you want to run K3S, you're just going to be downloading the binary. You can get it from our release page. So let's see. All right, good. So download that binary. So you're basically just going to run K3S server. So I'll show you the help here so you can see what this binary is. It's just basically server, agent, kubectl. These are the things. So if you want to run the server includes API server, controller manager, and scheduler. So this will get the server up and running. it takes a second for that to come up. While that's coming up, just since I'm pressed for time here, if you want to join, like when you launch the server, by default, it registers an agent on the same node, so you get a single node cluster. If you want to join another node to the cluster, you just run this k3s agent command, which it tells you on startup, and you have to get the node token from this file. Let me background that.
Just want to jump in and say you've got just under 2 minutes left. No
Cool,
pressure,
yeah,
though.
done with the demo. Super simple. Before I run that, let me just show you real quick. K3s, kubectl, get node. Did I already? Let me see. Oh, I think I still have, because I did a test before, so that it shows 2 nodes before that one is actually joined. I think I left the database still there. But anyway, so once you run that k3s agent command, it then joins. So now I have a full cluster. If I look at what's in Kubernetes by default, what we're deploying, because we try to make this fully functional. Basically, we package core DNS, that's there by default. We're using traffic as an ingress controller, so you automatically get ingress. We have this host port-based service load balancer. So if service load balancer works, it just will use host ports, which for a lot of our use cases, that makes sense. So pretty much the only thing we don't have right now is a built-in storage provider, and we're working on getting that before we GA. But it's pretty much a fully functioning cluster. So if you actually want to install this, I do actually recommend the curl script. It's just, you can download the script and run it yourself. You don't have to go through curl if you don't really care. But if you run the actual curl script, it's going to do a better job of installing because it'll set it up in systemd. So let me just show you this, and then my demo's done. Sorry if so. Get k3s.io. If you actually run the curl script, that's actually going to set up, a proper systemd. So do status k3s. It also sets up some symlinks, so you don't have to type k3s kubectl. Instead, you can just type kubectl get node. But there you go. It's up and running. That's pretty much the whole demo. Thanks for listening. Our website's k3s.io. There's our GitHub. It's pretty active. We just launched this about a month ago, and we've got a really positive, good response. So that's it. I don't know if they're open for questions or.
Yeah, thank you, Darren. That's a really cool project. Does anyone have any questions to ask?
Hey, Sai Santosh here. This is a nice demo. I just have one question, one basic question, like how this will be different from our regular Kubernetes cluster, and what makes us think about this particular project?
Well, I mean, in the end, it's still supposed to be like a CNCF. It's like, so it's from a user perspective, it should behave the same. So the difference from the cluster is it's just, it's a little lighter weight on memory footprint, and it's easier to kind of install and embed. So yeah, I mean, it's like, it's still just Kubernetes. I mean, yeah, so that's basically it, I think.
Okay, thank you.
Anyone else? Awesome. Thank you again, Darren. Really cool project. Next up, we have a demo from some folks from InfraCloud on BotCube. Are you ready to present?
Yeah. Thank you, Dilip. So I'm sharing my screen. Okay. So let's start. Hello, folks. My name is Prasad. I'm from InfraCloud Technologies, Pune, which is the first Kubernetes partner in India. So today I'll be talking about BotCube. So this is the agenda for today's talk. We'll discuss what we are trying to solve, how BotCube helps in solving that issues. Then we'll see end-to-end workflow of this BotCube. architecture, how you can write a filter and roadmap. Okay, so what exactly we are trying to solve with BotCube? So in typical software development lifecycle, once you develop your application and deploy it into the Kubernetes cluster, the next most important thing you need to address is monitoring. So it would be awesome if I get real-time notification about the failures in my deployments in Kubernetes cluster. And once the failure occurs, I may want to escalate that issue to respective developer team. So there should be an easy and quick way to debug my Kubernetes applications. And if I have multiple clusters, then there should be a common platform by which I can access any required cluster. And so when I create a Kubernetes resource, then I should get a recommendation about the best practices to create the resource. So how BotCube helps? So BotCube is basically a Slack app which monitors your Kubernetes cluster, which you can also use BotCube to debug your Kubernetes deployments. And BotCube also runs the specific checks on Kubernetes resources and provides you the best practice recommendations about the best practices for creating that resource. Okay, so rather than talking too much about BotCube, I'll show you BotCube in action. Okay, so I have a workspace which has BotCube installed in it, and if I do BotCube ping, I'm getting response from the BotCube backends. So this means I have two backends for this BotCube application. One is in GK stage cluster, another one is in GK dev cluster. Okay, so if I create, so this is the pod specification, which has one container. And if I create this resource, I'm getting notification about the lifecycle events. Okay, now I can see the pod is failed. Yeah, so this is how BotCube helps you monitoring your deployments. And if I want to debug this application, then I can also, so how BotCube basically helps you in debugging the applications. If you see help, then you can execute kubectl command as it is using BotCube. So I'll just do BotCube get pods. Okay, so I'm getting response from the BotCube. And so I may want to check logs of the failed deployment, right? So I'll just do BotCube logs and pod name. Yeah. So as I can see, there is a typo in the config file path. So I'll just quickly fix this. Yeah, and recreate the pod. So as you can see, when I delete the pod, then also I got the notification. Okay. Create. Okay. So with the lifecycle events, I'm also getting the recommendations saying that latest tag should be avoided. And I'm actually creating this pod without any labels. So I'm also getting recommendation that you should also add labels to the pod. Okay, so this is how you can debug your Kubernetes applications right from the Slack window. Another thing is, so as you can see, I have multiple backends for this app. So I can access any cluster right from the Slack window. So if I have to access, suppose GK dev cluster, then I'll just give cluster name flag with the cluster name. Yeah, as simple as that. So you can also manage notifications using the BotCube commands. So you can just say BotCube notifier stop. and it won't send you notification. Okay, so I have 2 clusters, and I have configured GKE dev cluster with to post events in stage alert channel, and I have another backend in GKE dev cluster which posts events in dev alert channel. Okay, so like that. So it solves our monitoring issue, and it also provides quick way to debug your application, and also gives you recommendation about the best practices. Okay, so this is the end-to-end workflow for BotCube application. So BotCube can be divided into 2 parts. One is you install Slack app, BotCube Slack app in your Slack workspace, and you need to install BotCube backend in your Kubernetes cluster. So one Slack app can have multiple backends, as I showed in demo. So depending on your configuration, BotCube registers informers on the API server and listens for the Kubernetes events. Once it gets events from Kubernetes API server, it forwards those notifications to Slack, your Slack workspace or Slack channel. Okay, so you can, for two-way communication, BotCube backend listens for the messages from Slack client and runs kubectl commands and sends response back. So BotCube has read-only service account, or I can say you can control or restrict the execution of certain commands, or restrict access to the certain resources using the roles you bind to the service account for BotCube. Okay, so going deep into the BotCube backend architecture. So in BotCube backend, we have informer controller, which depending on your configuration, register informers on Kube API server. Once you get event from Kube API server, we have event manager, which transform standard Kubernetes event into BotCube events by getting only required information from Kubernetes event. We also have a filter engine, which runs filter on the Kubernetes specs and add recommendations to the BotCube event. Okay, so once we run the filter, the notifier actually sends your BotCube event to Slack channel. For two-way communication, we are using Slack RTM client, which listens for the messages from Slack, and the executor executes kubectl command and sends response back. Okay, so this is the configuration you have to provide for BotCube backend. I think this is too small, so yeah. So BotCube has very fine-grained configuration. So you can configure you can configure the resources you want to watch, from which namespace you want to watch, and the required lifecycle events you want to get notifications about. Okay, you can also configure the warning or error levels of the events. You can turn off the recommendations if you want, and then you have to provide the settings or access token for the Slack communication, basically. Yeah, so this is very fine-grained configuration you can provide. You can also write your own filter.
Just want to jump in and remind that we're almost at time here.
Sure. So this is the standard workflow for writing your own filter. So we have a filter interface. You can write a Go function to satisfy the filter interface, which will run checks on the Kubernetes specs depending on your policies and add recommendations to the BotCube events. So yeah, this is the roadmap. So we already have added Mattermost support in our latest release. We will be also adding integrations with other benchmark solutions like KubeBench and all. And we'll also try to provide support for dynamic loading of filters. Yeah, so that's all I had. If you have any suggestions, or you can just visit our GitHub page and file issues. You can also join our Slack channel by join.botkube.io. Yeah.
Neat.
Yeah,
Thank you for that presentation. Does anyone have any questions? Going once. Oh, go ahead.
Hey, Prashad, you mentioned somewhere about that access control, right? So is that fine-grained access control is available in this BotKube?
Access control. So as of now, we only provide access to only certain commands. If you see BotKube help, then we are only providing access to commands like get, logs, so read-only kind of commands.
Okay, thank you.
Any other questions? Okay, thank you for that demo. Next up, we are going to have someone from the release team talking about the current release development cycle. So I believe this is Claire Lawrence. Are you ready?
Yes. Hello. Hopping on today to introduce myself to the community, since I don't normally attend this meeting, but will start doing so to give 1.15 updates. I'm going to be the release lead for 1.15. Formerly, I was the enhancements lead in 1.14, release lead for 1.15. Sorry if I confuse those numbers. Yeah, we're going to be planning to kick off the release cycle next Monday. So for all the SIGs out there, start expecting to hear more from myself and our incoming enhancements lead, Kendrick, around what different enhancements are being tracked for this cycle. We are going to keep doing the KEP process that we did in 1.14. So every single enhancement must have a KEP in an implementable state by enhancement freeze, or it will be removed from the 1.15 milestone. Yeah, and if you have any questions for me, feel free to ask them here or reach out via Slack in SIG release. Also, as a warning, I have no cat t-shirts, so I will not be able to one-up Aaron on that one.
Val, you're muted.
Sorry about that. I see that we have the patch deadline coming up for the 1.14.1 patch this Friday. So if you need to get anything in, now is definitely the time to make sure that's sorted. All right. Thank you, Claire. Next up, we have, sorry, someone just garbled my notes here.
SIG node will be first.
Thank you. Okay.
Sorry, that was me.
Yeah. Okay. So Signode, are you ready?
Yeah. Give me 1 second to share my screen.
Sure thing.
Let's see. Are people able to see my screen? Or hear me?
Yes, we can see it.
Okay, good. Thank you. All right. How do I get rid of this? Go away. Okay. I'm Derek Carr. I co-chair SIGNode with Don Chen, and I'm here to give our community update. And if people have questions, feel free to interrupt and ask away. So what did we do last cycle? So we have a recurring theme in SIGNode to try to improve both the reliability and support for more workloads. So on the improved support standpoint, we've done a lot of work with SIG Windows to help graduate Windows Note support to GA. So that was a big accomplishment, and now it's something that's been going on for a long time in the community, and so we're really happy to see that. As well, on supporting more workload diversity, there's been an effort that's been underway for a while around the concept of a runtime class. For those who aren't familiar, a runtime class is basically allowing Kubernetes to be aware of a particular runtime you need to run your pod. So if you would like to isolate your pod in something like Kata or gvisor or runc, an admin can use a runtime class concept to make that known to Kubernetes. And that particular feature had promoted to beta as well. On the reliability front, we closed the loop on a long-standing issue we had around being able to limit PIDs. So while we've been able to detect PID pressure, and we actually had a while where it was not working right, we've closed that out in this past release. So we now have a feature gate that is beta and on by default, where you can have the kubelet put a cap on the number of PIDs a given pod may consume. And so that pod can't fork bomb your entire cluster. And then we have a new feature as well, which allows you to reserve a set of PIDs for your node agents, similar to how you can reserve CPU and memory. And that feature was introduced as alpha, and we're looking to accelerate its move to beta shortly. And then as well, like every release, we do a number of bug fixes to try to just improve reliability, because at the end of the day, a lot of people are depending on the kubelet to run their workloads reliably. And then finally, we've had a number of features that lingered in beta for a long time that we graduated to GA just as an overall cleanup. And so one was around huge pages. So we have a capability to consume pre-allocated huge pages in your pod. And we've moved that to GA after sitting in beta for, I want to say, 3 or 4 releases. And then the labels we use to describe the operating system and the architecture on the node also moved to GA. And this is probably important for folks to make sure they read the release notes on, because the old labels will go away in a future release. We're still working through our plans for the upcoming cycle. And I gave a link to our areas under discussion, which when folks want to review the deck afterwards, they can. But there are kind of 8 high-level areas we're exploring and still working through. So the one is just code cleanup. So the CRI is an API that allows you to plug in different container runtimes behind the kubelet. It has existed in the kubectl repo for a long time, and it's now moved to its own dedicated repository. So that's a good thing. We are also in discussions to try to figure out improvements around vertical pod autoscaling, in particular allowing you to change the amount of resources a given container may have without needing to reschedule that pod. And so we're still trying to work through the design issues on that. And if people are interested, we'll link out to the KEP here. For a long time, we've been trying to improve performance for performance-sensitive workloads. And so there's some great work that is coming from, I guess, our friends at Intel and NVIDIA, where we're trying to improve CPU and device topology alignment, so that if you have latency-sensitive workloads or GPU-sensitive workloads, the kubelet does a better job scheduling you. And the KEP for that is, I think, in an implementable state, so hopefully we can start getting the code in this release. Then, while we talked about runtime class graduated to beta last release, we're trying to do some work this release to improve topology awareness scheduling around that. And so this is a KEP that's been going on with SIG scheduling. And then unique to runtime class is for some runtimes, like say you're using runc, the overhead of running your container is relatively small. But if you run your container in a different type of container isolation technology, sometimes that overhead is much larger, and so you need to account for it. I think we're still working through the right way to do that. There is a proposal out that we're working on, and basically the idea is that you can associate a certain amount of fixed overhead for a given pod, so that if the pod says I want this much resource, in reality it's going to take this much resource plus overhead to really run and schedule it. And then prior to our last release, when we talked about the PID limiting feature, we want to get node PID reservations to beta. We've had a rather long discussion on sidecar containers, which hopefully with SIG apps we can start executing on this release, as well as this long-standing feature request to do debug pod support, which hopefully we can continue to move forward. So a lot of interesting stuff going on in SIG Node if people want to join and participate, and if those topics are of interest. Or if there are topics you didn't see that you'd like to raise, we're always welcome to getting input. So how do these plans affect you? So I think the pod overhead proposal probably has some relationship to SIG autoscaling, in particular for anything that might be going on around vertical pod auto-sizing. And the desire to be able to support in-place updates of pod resources is so that if you do punt like a vertical pod autoscaler against a pod that's running, rather than getting a whole new pod when you resize your request, making the vertical pod autoscaler aware that pods could potentially resize and not need a newly scheduled pod is the idea with this cap that we'll have to work through. And then, like I said, for SIG scheduling, runtime class aware scheduling is something that we're working on right now. And then one thing that I think everyone should be aware of was we have recently deprecated support for containerized kubelets, just as a consequence of our ability to focus on supporting and testing and the challenges we've had in keeping that running across SIG Node and SIG storage. We had recently deprecated that. Things we need from all of you in the community. If any of these topics discussed here are of interest, we'd love input from everyone, both SIG members and users alike, on the KEPs as they finalize. A roundup of some of our subproject status. So like I said previously, the CRI API has moved into its own separate repo. So I guess if you're interested in building against the CRI, look here. And you'll see evolutions to the CRI happen in that repo first. The cri-o project had previously been sponsored by SIG Node. It recently got accepted into the CNCF. The project is in the process of moving, and the project will soon be housed in this new GitHub location. So if you are a user or a contributor to the cri-o subproject, you're probably already aware of this. But there will be a new home. And congratulations to the cri-o subproject for their adoption into CNCF. The cri-tools project is another subproject that SIG Node sponsors, and it's continuing to just improve this CLI and validation tools for debugging any CRI-based runtime. So if you are running Kubernetes in production using a particular CRI, you're probably already familiar with debugging it using cri-ctl. But if you have enhancement requests, please bring them forward to this repo. And for the main point, most of the work that's happening here is just keeping up with any latest changes to the CRI and kube releases. The node feature discovery project continues to evolve and I guess just detect more things. So if wanting to understand and inventory what hardware is on your nodes when you're running in production so you can schedule to them differently, please join the contributing community here in node feature discovery. SIG Node had previously sponsored a working group with SIG scheduling around resource management and trying to figure out the boundaries for what would be done in various parts of the project. And over the last year, a lot of the things that we actually just recently graduated or features that are already in beta were a consequence of this working group's discussions. At this point, we've decided to expire the work group for the moment and focus on actually executing on delivering the last previously defined items in normal SIG Node operations, in particular hoping to focus on CPU and device alignment. For everyone who did participate in that working group, a big thank you. I think we got a lot of work done in the last year in that space. How you can contribute, join our SIG meetings and basically let us know your interest. Hopefully everyone's friendly on Slack, and we always love to hear people's issues and challenges and how we can do things to make them better. And so where to find us, you can reach out to both myself and Dawn, who chair the SIG, but we have a great cast of engineers who help regularly contribute and participate, and I'm sure everyone would love to hear from everyone. With that, that's basically the update. So thank you.
Thanks, Derek. I know my team's quite excited about the sidecar cap. Does anyone have any questions? Going once? Going twice? Okay, next up we have a representative from SIG CLI for their community update.
Can you hear me?
Yes.
Okay. I'm Sean Sullivan. I'm the co-chair for the command line interface SIG. And I'll give a quick update. So we updated less than 3 months ago in mid-January. So this will be what's relevant over that last 3 months. So just a quick reminder of what the SIG CLI is, what the command line interface SIG is. We focus on command line tools and libraries that interface with the Kubernetes APIs. And here's a list of our sub-projects. You'll notice the last one is named Krew. So that Krew has joined as a sub-project of the SIG CLI within the last 3 months. And I've got some more information on that coming up. But first things first, we have a new logo for kubectl. And thanks to Ashley McNamara for creating this. It's a play on the cuttlefish. And if you don't pronounce it as kubectl, then I guess you'll have to come up with a different logo. Okay, so what are the announcements from the SIG CLI? So one of the more important ones is that kubectl is moving out of core and into its own repo. This is going to affect a couple other SIGs. I have more information on that coming up. As I mentioned before, the Krew plugin manager has become a sub-project of SIG CLI. Kubectl apply server side is alpha in 1.14. It requires enabling a feature gate on the API server. There's some new documentation on kubectl. The kubectl book, which again, I'll have more information on in the future. We want to mention also here that the export flag for kubectl get is deprecated. It will be out in about a year. So here's some more information on our effort to move kubectl out of core. So in the near future, there will be a KEP describing the steps. We will welcome the feedback from the community on that. This effort is mostly going to affect, we believe, SIG release and SIG testing, and we will especially be soliciting feedback from those SIGs and coordinating with those SIGs during this process. As part of our kubectl independence effort, we have deprecated kubectl convert. Since this command contains dependencies that kind of tie kubectl to core, we basically can't have this command anymore if we're going to pull it out. This command will be removed by 1.17, but if you rely on this functionality, we will probably be continuing the functionality as a plugin. Please contact us if you have any concerns around this. Here's our new repo name, and any questions, contact me. So we're happy to announce that Krew is a subproject of the SIG CLI. Krew is for kind of the day 2 and day 3 efforts for plugins. It allows for plugin management. So Kubernetes is not going to be managing an index of plugins, but we will provide the tools so that organizations who do want to manage plugins will be able to do that. That's what Krew does. So it kind of fills in a gap that we had in our plugin story that allows, as I mentioned, the kind of the maintenance, the upgrade, and the discovery of plugins. If there's any questions related to Krew, please contact Amit. Okay, so as I mentioned before, we're happy to announce that Apply has moved to the server side. So here's a rundown of all of the movements that have happened in regards to this. Back in 1.13, kubectl diff and the server-side dry run already went to beta. And so here's a link for the blog to the diff. As I mentioned before, there's a feature gate since this is alpha that's necessary to be enabled for your API server to implement this functionality. And if there's any questions, contact Antoine, please. Okay, so we have some brand new kubectl documentation. This emphasizes declarative management of your apps or your deployments, but it covers all of kubectl functionality. We're soliciting feedback now on this new documentation, so please have a look, and especially you should funnel your feedback to Phil Whitrock for this. So here is a rundown of some of the outstanding KEPs that may be of interest to the community. There's a couple for customize for our and a couple for kubectl. I'm not going to go into these here, but if any of these interest you, please provide your feedback on these KEPs. And what do we have next? And so finally, this is just a set of links for how to talk to us at SIG CLI. And that's about it. Are there any questions?
All right, thank you for presenting the update. Running a little bit tight on time. Lastly, for SIG updates, we have an update from SIG Network. Are you ready to present? Is that a no?
Hang on, sorry, I lost my window for a second. Let me see.
All good, just want to make sure we didn't lose you.
It's, if you open the link, let's see.
Derek, you need to stop sharing. Sorry, SIG CLI, you need to stop sharing your slides. There we go.
Uh-oh. Help.
Okay,
Looks
now.
like it did it.
Yep, now try sharing.
Oh dear. Valerie, is it okay if you share the slides?
I
Not too many.
can try.
I got you, give me a second.
Okay, thank you.
Okay.
It's always fun doing it live.
Whoops, that's Node.
Oh, nuts.
It's in the doc.
Yes, sorry.
There you go. All right, it's very short.
Oh, perfect.
So, hi, I'm Bowie from SIG Network, and we gave an update in January, so this only covers the past 3 months. Can you go to next slide? So SIG Network, we cover all of the networking associated with Kubernetes. So this includes pod networking, CNI, service discovery, which is DNS, load balancing and services. So these are resources, service, endpoint ingress, and then network security and network policy, and other miscellaneous network related things not in this list. In terms of things that happened, so next slide, please. So stuff that happened. Ingress v1 was moved into the network API group, but still beta. We did this move in 1.14, so please update your code references. There'll be quite a few cycles as outlined in the KEP in terms of deleting it from the extensions group. But if everyone updates their references, it would help sort of clean that dependency up. We spent quite a bit of time resolving wrinkles with Windows conformance as part of the networking aspect of conformance. We have a KEP in flight for cleanup of kube proxy cleanup behavior. I'm being a little too cute in these sentences here. Also, as part of joint work with API Machinery, we have a network proxy KEP. This basically is, it's interesting, the K3S presentation had this reverse tunnel. This is kind of adding that API into the API server officially as part of Kubernetes. Please take a look if you're interested. This replaces the SSH tunnels code that exists. Finally, the pod custom DNS feature went GA in the past 3 months. Now, in terms of what we're looking at for the next 3 months is, first we have a KubeCon Barcelona deep dive session on networking. So please attend if you're going to be there. No local DNS is going to go to beta. And we got some pretty good feedback regarding the need for HA and other features, and we're going to try to get that into 1.15. Also in 1.15 is sort of figuring out Ingress v1 scope and GA plans. This basically is going to build on moving the Ingress out of the network API group and then towards GA. And then there's work on finally having service finalizers, which is basically when a service is deleted, the associated cloud provider resources are also deleted. And then to note is that the 1.15 planning is ongoing. So please, if you have something that you would like to see happen in 1.15 or maybe 1.16, please come to SIG Network and put something on the agenda. And then things that keep happening is we are running a bug triage in every session. Thanks, Tim, question mark.
I do appreciate the question mark.
So that is something that we're doing. And then just one random shout out is that if we recently had a blog post on Kubernetes blog about a pretty cool bug. So if you like subtle bugs, that one is an interesting read. Okay, go to the next slide. Oops. Okay, thank you. So where to find us? Our Zoom meeting link is there. And then sort of the ways to find our mailing lists and GitHub repo, the links are all there. And that's it.
Thank you. Any questions? All right. Thank you for attending this week's meeting. Before we wrap up, I want to pass on some of the shout outs we've had. So we have a shout out for, oh boy, reading Slack names is not great. Frick for consistently stepping up to review PRs in Kubernetes org and other contribx repos. Shout out to Justin SB for working on the v1 alpha1 release cluster API. I had a shout out for Liggett for the huge amount of contributor and development questions he's been answering all around the community. We have a shout out for Leah around the work on documenting and managing cluster API use cases. And this week, our top 10 Stack Overflow users are, all right, well, I can't pronounce this list, I'm sorry, but you can read them on the meeting notes. So that's it for this week. Thanks everyone for joining.
Thanks.